Alright, dear students, let's get to see what will happen if I add water to the acids and bases. Let's see. Now I'm adding the water to the different acids over here and the different bases over here. Alright. So let us take the examples of acids to be CH3COOH and HCl, H2SO4 and HNO3. Sorry, we have HNO3. So here I have taken the examples of 4 acids which are commonly used in the laboratories, and we need to see what will happen if I add water to these acids. It is observed that students, whenever I take these acids and add water to them, or take the water, if I take the water and add acids to them, it is observed that these compounds which are there, the acids which are there, they will dissociate into their ions. Basically, dissociation of ions will happen wherein the acids will dissociate into CH3COO minus H plus. Here also H plus Cl minus. Here also H plus SO4 minus. Here also H plus NNO3 minus. So if I see all these acids, the common thing that I have is the presence of the hydrogen being a cation. So I could say that all these ions, they have a common cation that is nothing but H plus. Now this H plus, just because it is there in water, H plus is not stable. So this H plus will try reacting with water, leading to the formation of H3O plus ion, which is also called as hydronium ion. It is also called as hydronium ion. So whenever we want to say that H plus is there in water, we either write it as H plus aqueous, or else we say that it is the hydronium ion represented by H3O plus. So now we understood that all the acids will have H plus ion to be common in them, and whenever the water is added to them, the water splits in such a way that H plus cation gets separated from the anionic part of the compound. So this is what happens when the water is added to the acid. Next, let us see what will happen if I add the water to the bases. Let's take the examples of bases to be NaOH, MgOH twice, CaOH twice, and potassium hydroxide, that is KOH. It is observed that whenever I add the water to the bases, these bases will also dissociate into their ions. Here also dissociation process will take place. Now it will take place in such a way that the metallic part gets separated from the other part like this. So here also dissociation will happen as Mg plus NOH minus, Ca plus OH minus, K plus NOH minus. So here I get to see that in all the bases, the common ion is OH. It is a polyatomic ion, and this OH ion is an anion. Here we saw that all the acids will have a cation in common, and here we are seeing that all the bases have an anion in common, which is nothing but OH minus. Now we got to know that all the acids have H plus in common and all the bases have OH minus in common. Now the question arises as, see, I had all the acids, right? For example, if I take HCl, only HCl molecules were there. In a particular volume of acid, if I take, all were the HCl ions. Now the moment I add water into this, no more HCl is there. Rather, I have the ions as H plus and Cl minus. That means the molecules of acid per unit volume is reducing. That means Whenever I add the water to acid, this acid gets diluted because I have very less acid molecules in a particular volume of acid. Same thing happens with bases also. Whenever I add water to the bases, the dissociation of ions will happen, and as a result, the molecules of base per unit volume goes down, and I say that the base gets diluted. So whenever water is added to either acid or bases, the process of dilution will take place due to the dissociation of ions into the water. If it is an acid, the H plus ion which is produced, it reacts with the water present in the environment and it becomes hydronium ion which is H3O plus, and the bases will have OH minus ions in common. Now we know that the concentrated acids which are there, the pure acids which are there without any water in them or very less amount of water in them, they are the bad conductors of electricity. That means if I take the pure form of, NaOH or calcium hydroxide or acetic acid, or if I take the hydrochloric acid and make the electricity pass through them, I get to see that electricity will not get passed because it is the pure form where water is not there. But to that simple acid or a base, if I add a bit of water, the dissociation of ions will take place. These ions which are there in the medium will help in conduction of electricity. That's the reason why we say that dilute solutions of acids and bases conduct electricity. This is one thing. Now, during the dilution process, can I add water to acid or should I add acid to water? Basically, if you want to dilute an acid or a base, it is an exothermic reaction. Exothermic reaction is a reaction in which heat is given out. This reaction of addition of water to acids and base, it is highly exothermic in its nature. So, if the water is added to a large quantity of acid, the heat generated will make the mixture splash on the face. It causes burns because it is acid. Or else, the container in which you have taken the acid and then adding the water, if that container is of glass, the glass might break due to extent of the heat which is generated over here. That is the reason why it is always suggested that take water, then add the acids drop by drop through the walls with continuous stirring, so that all the acid molecules which are added into the medium, they get utilized and the heat generated will get balanced over there. So it is always suggested that acid should be added to the water, never the water should be added to the acid. The same way goes with the bases also. Whenever you want to mix water and the base, you have to make sure that the water is slowly added to the base with continuous stirring. This is what in today's video we were supposed to cover, wherein we studied that whenever the water is added to the acids or the bases, the dissociation of ions will happen, which leads to the formation of cations and anions. We observe closely all the acids. There is one common cation in all the acids, which is H plus. This H plus, just because it is not stable, will react with the water present in the medium and then it forms the hydronium ion. So whenever we want to represent the hydrogen ion which is there in the acids, we either write it as H plus aqueous or else we write it as hydronium ion, that is H3O plus. Coming to the bases, whenever the water is added to them, dissociation of ion will lead to the formation of cations and anions, and we have observed that all the bases will have OH minus ion to be the common ion in them. Now, the more water is added to any acid and base, we get to see that the more dilution takes place, because whenever more water is added, more and more acid and bases molecules will dissociate into their ions, which leads to the decrease in the amount of molecules of acids and bases in a unit volume. and that's the reason why the acids and bases will get diluted. So for the process of dilution of acids and bases, always the acid or base should be added to water. We should never add base to the acid, or we should never add water to the base or the acid, because the reaction is highly exothermic. It can make the reaction mixture splash on the face, or else it might break the container in which the reaction is taking place. So this is all about what all the acids and bases have in common, what will happen if they are made to react with the water. See you in the next video.